Hey y'all, it's me, Miss B. Today we're verifying trig identities. So first let's go through the rules and the basics. So to verify an identity, we need to show that one side of the equation is identical to the other. That key is one side. All right, because we're only allowed to change one side of the equation at a time. All right, a lot of people are going to make this mistake at least once where they solve both sides and then they make the middles meet, but that's not how we solve trig equations, okay? So it's really important we only do one side at a time. Another thing is that we can't skip any steps. Some things might be obvious to you, but we have to assume that nothing is obvious. So I'm just going to write assume nothing is obvious. So we want to show every single step. Also, another thing is we can only use identities to go from step to step. We're going to use sine and cosine to help us solve. This is more of a hint. It's not an absolute necessity, but most identities use sine and cosine, so that is why I tend to bring it all back to sine and cosine. And then sometimes we'll have to use algebra to verify the identities, but not very often. Okay, so on a separate sheet of paper or on a sheet that was given to you, you're going to write in these identities. So here's our identity sheet. It says fill in the blank trig identities. Now these ones we already know. So reciprocal identities, sine is equal to 1 over cosecant. Cosecant is 1 over sine. Cosine is 1 over secant. Secant is 1 over cosine. Tangent is 1 over cotangent. Cotangent is 1 over tangent. Those are the reciprocal identities that we reviewed in chapter 4. The quotient identities, tangent is equal to sine over cosine, and cotangent is cosine over sine. Then finally, for even odd identities, just remember that cosine and secant are the only ones that if you put a negative in, you get a positive out. These ones won't be used as often, but they are important, so you do need to memorize those. So go ahead and write those down. Pause if you need to. I'm going back. All right, so here's kind of my note for these examples, okay? They are... I'm going to walk you through one and how to do it, and then you might want to pause and try one on your own. Every single problem can be done a different way. So one person might do it in 2 steps, one person might do it in 5 steps. I'm going to do it in 3 steps. As long as you're getting to the correct answer at the end, it doesn't matter how you got there. Every person's going to have a different route that they took to get to the final answer. Okay? So you definitely want to be using pencil and eraser because this is the kind of thing where it's a little bit guess and check in some areas. So I'm walking you through just to get a general idea of how to do these. The only way that you're going to learn how to do trig identities is by doing them yourself. Okay, so I see here that I have cosine and cosecant. This is what I was saying. So I'm going to start with the side that has more stuff for me to work with. I really don't want to leave it as cosecant, so I'm going to write this as cosine of x times 1 over sine x. That way I'm in terms of sine and cosine. All right, so I'm working from the left side only. And this identity that I used was the reciprocal identity to get 1 over sine x. So then I'm going to multiply those together. So I have cosine of x over sine of x. That's just multiplication. Okay, so that didn't even use an identity. That's just multiplication. Cosine over sine is cotangent of x using that reciprocal, that quotient identity. You'll notice that we got cotangent, and cotangent is what we wanted, so we have proved. I like to just use a little check mark to show that I got what I wanted in the end. Okay, so it's as easy as that. You're just working through it step by step, seeing if we can find identities throughout. I would strongly suggest having that identity out next to you. All right, let's look at number 2. Okay, so first up here, I have cotangent of negative x. I'm actually going to write this as negative cotangent of x sine of x. And all I did there was I used a even odd identity. I'm going to go ahead and rewrite cotangent as cosine over sine. So we have negative cosine x over sine x times sine x. And that was using the quotient identity for cotangent. You'll notice that these signs cancel out because that's multiplication. And so we're left with negative cosine of x. And to get there, we used just multiplication or simplifying. We get negative cosine of x. Negative cosine of x. Negative cosine of x is what we wanted. So we're done with that identity. Okay, so the key is to know your identities and know them well enough that at any given time you can rearrange them. So the better you know your identities, the better at these you'll be. Okay, so I would strongly suggest going ahead and pausing here, trying this one on your own. So here we have cotangent x. So I'm going to write this as cosine of x over sine of x. And then secant is 1 over cosine of x. And sine is just sine of x. So we are allowed to combine more steps into one. So we use the quotient identity and the reciprocal identity. If at any point I ask you, what step did you take, then you didn't show enough work. All right, so then cosine cancels with cosine, sine cancels with sine, so that's sine over 1, and that is equal to 1 when we multiply straight across. So that was just multiplication and simplification. Okay, so then we're done. Okay. Number 4 and 5 are so similar to number 3 and 2. So I'm actually going to skip those ones for now. I would go ahead and try them on your own. I do want to do number 7 though. So for number 7, I've got a little bit more of a complication here. So we can actually solve this 2 different ways. We can solve it from the left and we can solve it from the right. I'm going to show it both ways. So starting from the left, I have 1 plus sine theta over cosine theta. So I'm just rewriting what I already have. I'm going to rewrite this as 1 over cosine of theta plus sine of theta over cosine of theta. So all I did was separate those fractions into two different fractions. We have the same denominator, so if we were to add those together, we would get the same thing. Now, let's see where we're going. We're trying to get to secant and tangent, and we're given 1 over cosine and sine over cosine. You should notice straight away that 1 over cosine is secant of theta, and sine over cosine is tangent of theta. So we do end up with our final answer there of secant theta, tangent theta. Okay, but some people may have thought, I think secant of theta and tangent of theta, that side might be easier to work from. So let's go ahead, come over here, secant of theta plus tangent of theta, and think about it a different way. So I'm going to rewrite this in terms of sine and cosine. So I have secant is 1 over cosine of theta, and tangent is sine of theta over cosine of theta. I have a common denominator, so I can add those together. So I get 1 plus sine theta over cosine theta, which is what I had on my left side. So the left equals the right. Okay, either way is right. It's just a matter of how your brain works and how you like to think about these equations. Okay. I think I'm going to leave it there and then leave the rest for you to try on your own.